Hello and welcome. In this video, we're going to take a look at an introduction to systems of linear equations. Systems of linear equations arise pretty naturally in a lot of business and real-world contexts. We've studied linear equations before. We're kind of familiar with the idea of slope and y-intercept or vertical intercept, as we might call it. And now we're looking at sets of linear equations. So a system of linear equations is really just a set, a collection of two or more linear equations whose solution set is any point or potentially points that both equations share in common. Okay, so you might think about this as if I were to graph two lines, two linear functions, and let's just say those are my two linear functions, then I can pretty quickly see what point, in this case, both equations share in common. Let's call this y1 and y2 for reference, and we see that there is one point that they share in common, namely the point at which those two lines intersect. So that ordered pair, whatever that corresponds to right there, let's just say that that's where x is 3 and y is 5. We see that the solution to this system is the point 3, 5. By the way, we've defined a solution. We say that's any point or points that they share in common. So in this video, we'll take a look at kind of the general structure of them. We'll see why we're even interested in solving them beyond just a mathematical curiosity. And then we'll take a look at how do we go about solving them. But this gives a good amount of insight. One way to do this is graphically. So a system of two equations might look like this. We have you could say a sub 1, 1 or a subscript 1, 1 times x1 plus a sub 1, 2 times x2 equals c1. And then a second equation, if we only had two equations, a2, 1 times x1 plus a2, 2 times x2 equals c2. You're seeing all these subscripts and you're thinking, why aren't we using just x and y? Well, the reason we do that is because we could have more than two variables. And we're going to run out of letters of the alphabet, so usually we just denote our variables with subscripts, variable 1, and we can think about this as variable 2. You could certainly use x and y, and in a lot of cases we will do that. We may use other letters other than x and y, but if we had more than two variables, we could just say x1, x2, x3. So we have two equations with the same two variables, and then these guys here are just the coefficients. And the reason we use two subscripts is because we like to think about this as kind of row 1, if you will. And so the first subscript denotes the row. So we're in the first equation, and it's the x1 coefficient. Here we have a1, 2, so it's still the first equation, a1, and then 2 denotes that that's the coefficient for x2. And then c1 we're just using to denote, that's some constant. Could be 0, it could be a positive number, it could be a negative number. And then once we get to row 2 or equation 2, we have, okay, now we're in the second equation, first coefficient of the first variable, second equation still, and the second 2 denotes that it's the coefficient of the second variable, and then c2 just denotes the constant for that second equation. So here's an example. We could have something like 3x plus 5y equals 10, and x plus 3y equals 17. And in this case, we see that if we match things up, here's our a11, our a12. What would a21 be? Well, there's a 1 there that I could write in, and then a22 is equal to 3. And here I'm just using the variables x and y, but again, those are just placeholders for variable names. And then I have my constants. And to distinguish constants from coefficient, a coefficient is a value that multiplies a variable. A constant is just a constant. There's no variable associated with it. So here's my c1, and then here is my c2. Okay. So this gives us a very general way of writing it. And here we're just pointing out that A11 through A22, C1 and C2 are all some constants. Great, so we have a little bit of insight into these systems of equations. Let's take a look at why we would want to study them. So let's say you start an Etsy storefront. You go on Etsy.com, you open up your store, you begin making things and you want to sell your products, get them out to the world. And let's say you decide you're going to focus on, because you don't want to make too many products, you're pretty good at making blanket ladders and candle shelves that people could put in their homes. You can only make so much each month. You have enough lumber that you've bought and enough time and energy to make 24 products this month. Maybe you can do 3 or 4 at a time, and you do these each week. You'd like to make $1,000 this month. We're just going to say this is pure revenue, so we're not going to worry about the cost of the lumber. A blanket ladder you're going to sell for $100, and a candle shelf you're going to sell for $30. Assuming you can sell everything you list, how many blanket ladders and candle shelves should you make? Okay, well, we're making some assumptions here, right? We're assuming that you make 24 products, you're going to sell all 24 of them. People love your stuff. You just can't keep things on the shelf. You'd like to make $1,000. You kind of want to know how many of each of these you should make to get as close to that as possible. Now, sure, you could make all blanket ladders, but maybe you know that if you sell too many blanket ladders, maybe those won't all sell. You want to have kind of a nice variation. You're just shooting for that 1,000 benchmark. So we're going to assume that you want this amount exactly. So how many should you sell? Well, that's the variable, right? How many begs the question of what quantity of blanket ladders and what quantity of candle shelves should you make? So we're going to create 2 variables here. Maybe we'll call those B for blanket ladders. And we'll say this is the number of blanket ladders you make. By the way, blanket ladders are just these. They look like ladders. People drape their blankets over the rungs of this ladder. It kind of has somewhat of a Southwest feel, if you ask me. And then you have candle shelves, and you want to know how many should you make of those. So the number of candle shelves you make, and this is unknown, right? That's why we're assigning variable names to these 2 quantities. Now you have equations that are sort of implied in this statement. You have enough lumber to make 24 total products this month. So that's one of what we'll call the constraints, right? You're not just going to make as many as you want. Your constraints is that you make 24 total products. That's required. That's what you need to make. Now, you also want to make $1,000 this month. Make $1,000. Okay. Now, your cost, what you're going to sell them for, $100 for the blanket ladder and $30 for the candle shelf. Sure, those are constraints, but they're not going to directly affect your end outcome here in terms of how many products and how much you're going to make. You're selling these at a fixed price. So to make 24 total products, let's think about this. The number of blanket ladders you make plus the number of candle shelves you make have to add up to 24. So B plus C has to equal 24. Okay, B plus C. Literally, we could read this as a sentence. The number of blanket ladders you make plus the number of candle shelves you make equals 24. That's 24 total items. Now, you also want to make $1,000. Well, how are you going to make it? Well, you're going to sell B blankets, right? That B could be 10. And if you were to sell 10 blankets, 10 blanket ladders, 10 times $100 per blanket ladder, that would give you $1,000 in revenue right there in and of itself. Okay, well, on top of that, you need to also sell some candle shelves, and those are $30 a piece, and you're going to sell C of those. So if C was equal to, say, 5 candle shelves at $30 each would give you $150 in revenue there. All right, so let's think about this in variable context. So you're going to sell B blanket shelves. Each of those will give you $100 in revenue. So 100 times B will tell you your total income from selling just the blanket ladders. Similar for the candle shelves, you're going to sell those for 30 bucks a piece. So you'll get $30 per candle shelf times C candle shelves will give you your total dollars of income from those. And you want to add them together because you want the total income to equal 1,000. Now we have a system of equations. Our system of equations in this case, we think about that general template again. I put coefficients of 1 in these. I can see again that I have that A11 is equal to 1. X1, our first variable, we're just naming it B in this case. Then we have A12, still first equation, second variable, times the second variable. And then down here we have A21 times X1 and A22 times X2. And we can think about this as our constant 1 and our constant 2. So now we have a legitimate system of equations whose solution will be the pair of values, or any pairs of values, B comma C, such that that ordered pair makes both equations true. In other words, B plus C adds up to 24, and simultaneously 100B plus 30C adds up to 1,000. So how we solve these equations is going to vary a little bit, but one way to think about this is just to graph these two lines. These are two lines, and you could always think about one of these variables as X and one of these variables as Y. So maybe you let X be B and you let Y be C, right? Because it was just easier to name them according to what the letters stood for than it was to call them X and Y and then forget which one's which. But one thing we could do is just, in most graphing utilities, enter these, and here I'm letting X be B and Y is equal to C. I have to use X and Y in most graphing utilities, so I just graph X plus Y equals 24, that produces the red line. 100X plus 30Y equals 1,000, that produces the blue line. And I see that the solution in this case, the point that makes both equations simultaneously true, is the point 4, 20. So that means that if I sell, or I should make 4 blanket ladders and 20 candle shelves, what will that accomplish? Well, it will ensure that 4 plus 20 is 24. So I'm making 24 products using up my lumber. And then 100 times 4 is 400. So I'll get $400 in revenue from the blanket ladders, plus 30 times 20, that's $600 in revenue from the candle shelves. And I can see that 400 plus 600 does indeed give me my $1,000 of income. So we have not only fabricated a system of equations here based upon a context, but we've also produced a solution. Now we'll talk soon about how we can produce these graphs and what happens if there are more variables, keeping in mind that in 2 dimensions you can only plot equations that contain 2 variables. If you had a third variable, you would need a third axis, and then we're getting into 3-dimensional stuff. And with 4 variables, now we can't even visualize it. So we're going to have to come up with techniques that allow us to do this more optimally. But before we stop here, how do we write systems of equations more generally when there are more than 2 variables? And this often is one of those things that can look a little big, I'll say a little big, but if we generalize our system from above and we say, well, here we could have as many variables as we want, x1, x2, dot, dot, dot. This just means it keeps on going, x1, x2, x3, x4, all the way up to some nth variable. So we have n variables, where n is going to be some positive integer, right? We could have 30 variables. It could go up from x1 to x30. And then we're going to have a certain number of equations. So the first equation may look like this, maybe a11 x1 plus some coefficient a12 x2. Remember, first subscript is what equation we're in, and the second subscript denotes what variable that coefficient is attached to. So we have a11 times x1 plus a12 times x2, plus we'd have a13 times x3 plus all the way up to, and this is how we write it, we say plus dot, 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 I have an extra dot in there, but that's okay, plus a, okay, we're still in the first equation, but now we're on the nth variable, so that's the coefficient of the nth variable in the first equation times xn equals some constant. And then we would do something similar for the second equation, a21 times x1 plus a22 times x2 plus a23 times x3 plus dot, dot, dot plus a2n, again, second equation, nth variable coefficient times the nth variable equals constant 2. And this goes on and on, depending on how many equations you have. Now, one of the misconceptions is that you have to have as many equations as you do variables, but that's not necessarily true. The number of variables that you have in our context is the number of products that you're selling. And the number of equations that you have is the number of constraints present. Here we just happen to have two variables and two constraints. Two variables led to, two constraints led to two equations. So we had as many variables as we did equations, but we don't necessarily have to have that. Let's just say that we have k equations. Okay, so where k could be bigger than n, we could have more equations than we do variables. So could have k, well, could be k is equal to n, right? That in other words, we have as many variables as we do equations. It could be that we have more equations than we do variables, or it could be that we have fewer equations than we do variables. We have more variables than equations. So the way we'll write this is we'll just say we have, okay, now this is going to be the kth equation. This is equation k, first variable coefficient, plus ak2 times x2 plus ak3 times x3, and on until we get to kth equation, nth variable coefficient times xn equals, and then we'll just write, this has got to be ck, because this is the kth constant that we have. And this is a way we might generalize that. Now, it just looks like there's a lot of uncertainty in this, and there is, right? Because this is going to encompass every single possible situation we could have by just writing this in this general form. But the idea is we have consistency. We have, notice, we have all the coefficients of x1, and then x1 is this entire column right here. This is going to become important a little bit later on. We have the coefficients of variable 2 times x2, and so on down the line, which is going to lend itself to a special type of form that will allow us to optimally solve these without having to worry about graphing or doing any sort of tedious amount of algebra by hand.